Welcome back, guys. Today we will be covering the topic of 4D printing technology. As I've mentioned from the title, we will be fabricating a 4D printed model. So, what is 4D printing? Before diving into that, we have one dimensional, which is a dot that can move in one axis. And then there's two dimensional, which is the inclusion of the y axis. And then there's 3D printed objects, which can move relative to the z axis. And finally, we have a 4D printed model, which can react to an external stimuli. The stimulus can be anything from water, electricity, light, and also heat, where one of the stimulus, when it's brought towards the 3D model, the visible change that can be observed brings the core definition of four-dimensional. Why is it four-dimensional? Because there is a change that is happening in terms of the particles in the 3D model. The particles change in shape and move relative towards the stimulus that causes a dynamic response of the 3D object. Well, I hope you guys understood the theoretical part of a 4D printed object. It's alright if you guys don't understand yet, because we will be going into making the 4D printed object. Right now in my hand, I have a vernier caliper measuring a magnetically responsive filament, which is also known as an MRE filament. So this filament is the filament that we will be using to print the 3D model object. To fabricate this MRE filament, we need two important materials, where the first one is iron powder. Iron powders are magnetically responsive, where it is physically attracted to magnets. The iron powder that I'm using will be carbonyl iron particles, known for its high purity. You can also use other available iron powders which are commercially available. The next material needed will be the polymer, or in this case, we are using thermoplastic elastomer, or also known as TPE. TPE is used to induce flexible properties to the filament, making the filament more flexible so that it contributes to more types of applications. So in this case, I am showing you a thermoplastic rubber. The fabricated filament was using thermoplastic polyurethane. So any types of thermoplastic polymers can be used to fabricate this magnetic filament. I've been talking about what is 4D printing and what are the materials needed. Now let's look into one of the two most important machines needed to fabricate this 4D product, which will be an extruder. This image over here is a Noztek Pro desktop extruder. And like I mentioned, the materials earlier, which is the thermoplastic polymer and the iron powder, will be dropped into the hopper of this machine, which will then produce the filament needed. I've attached the link of this product in the description below, and I will be showing you the extrusion method in my next video. But for now, let's straight dive into printing the product. Now, this is the second important machine needed, which is called a 3D printer. So I'm using the Bamboo P1S series. You guys can use any other recommended or commercially available printers there. It can be any other brands. But for me, I'm using a Bamboo P1S series. So as you can see, I'm attaching a top mount to hold the filament. Why am I doing this? It's because this MRE filament is flexible and has lower hardness. So over here, I'm going to insert this into the filament and then directly mount it on top. So yeah, it's done. So since we are not using this tube over here, I will remove this tube. So one of the way is you need a small device. It can be a screwdriver, it can be a hex screwdriver, or it can be an Allen key also. Or you can use anything that is this thin. So you just press this tension, we give a small tension over here. And slowly pull the tube. Yeah, that's it. And you can remove it from this attachment and just place it behind. Okay, so one of the steps to load this filament manually is first you must bring this extruder to the mill. So you can do that by manually controlling this thing over here. So just bring it to the middle so that it's easy to manually insert. Okay, so you hold this filament and directly insert it into the extruder, and you just insert it until you get the into you until you feel like there is something blocking. So that means it has reached the end of it. And then hold a bit to the top, not so near, and you have to manually load it. So one of the ways to manually load is go to this symbol E, press it. I'm sorry. One of the ways to manually load it is to go here, this temperature, press it, and adjust the temperature. For in my case, this filament will melt at 240 degrees. So go to 240 and then press. And at the same time, go to section E and press the down arrow. So wait for the filament to manually extrude, and you can see it coming out. So once the filament is coming out, what you can do is press the up arrow and then return back the temperature to its normal standard. I would recommend putting it back to 180. This is the interface of the Bamboo Lab slicer. So we will be printing 4 small cylinders with a height of 18mm. The cylinders will be the tires for a vehicle concept that I will be showing you later. And a big shout out to Recreus 3D Printing for giving the custom print profile. They do print soft types of materials. So since my material is soft and I'm using TPU, I went through their videos and it was really helpful. A big shout out to them. I've attached the link for their videos in the description below. And one of the key changes they made was actually modifying the G code of this 3D printer. So the G code over here is modified so that the feed rate is set lower. So the typical feed rate of a Bamboo Lab V1S, the default is 200 millimeters per second, but over here it is reduced to 80 millimeters. Now we have reached to the final part of the video. I've actually also printed a simple car chassis which has 2 holes in the front for the front tires and also the rear tires. I'll attach the link for the 3D model in the description below. So these printed tires actually have a small defect where it went through under extrusion at certain layers, as you can see over here. Therefore, I think more modifications need to be done to the printing parameter. However, for now, we just need a simple cylindrical model to act as a tire. So for now, it should be good for the application. And yeah, you will need 2 additional rods to insert into the center of the tires. The rods I'm using is a thin steel. You guys can also use any simple tools around you. For example, it can be a wooden stick or a long needle. Now let's get into the assembling process of these tires. Alright, we have now attached the whole tires into the chassis, and now I have a magnet in my hands. This magnet is ranging from zero point 0.1 to 0.15 Tesla. And yeah, boom, over here you can see that this magnet is attracting the tires. So the tires actually have a magnetic properties, and therefore this proves that 4D printing is possible. So which means that the magnet, when it's bring closer to the tires, the particles, the iron powder particles in the tires react by getting close to the magnet. So yeah, guys, this has finally proved our concept. Thank you for watching.